Hello, everyone. Welcome to the AWS Virtual Workshop Series on implementing operational excellence using AWS Management and Governance Services. This is episode 3, implementing observability with Amazon CloudWatch. My name is Bobby Hallahan, and I'm a senior specialist solutions architect with the observability team here at AWS. So let's jump right in. To quickly cover our agenda, we'll first cover a summary of observability and give us an overview of what we mean by observability. We'll then introduce a new AWS solution, which is called the Amazon CloudWatch Monitoring Framework, which is what we'll be walking through today. We'll then do a hands-on walkthrough of this framework and mostly discuss how this can help us with implementing operational excellence. And then we'll then also speak to a couple ways in which we can go about extending the monitoring framework to suit our workloads or customizing it to fit our needs. Alrighty, with that said, let's go ahead and chat about observability. So what is observability? Normally we think of it, and it comes in three different things. So we have detect, investigate, and remediate. When we think of detection, and let's frame this from the lens of think of a workload that you may be currently supporting, a workload that you're building, or a workload that you are previously familiar with, where potentially there was an operational event which led to some sort of service outage, which potentially led to some revenue loss. And think in your head of what were those steps that you took to that path. And normally we'll kind of follow this same model of there's that initial step of detecting the issue. There is a investigation phase where now that some sort of alarm went off, it's like 2 a.m, we got paged or something, we're coming in, or we have some sort of a operational team investigating this issue, looking at logs or metrics or trace data to try to identify what the root cause is. And then, of course, we have remediation of the issue is, of course, in which we go about trying to fix that root cause and bring our service or workload back up to a working status. But to dive in a little bit deeper into this, let's look at that detect phase. So from a detect perspective, we want to think of from the time the incident first occurs, and then the time we actually find out about it, or the time that an alarm goes off and we get paged. Normally, from an observability standpoint, this is where having well-defined alarms can be helpful. Alarming on things such as anomaly detection bands, so not exactly relying on static thresholds, looking at if there's anomalous behavior, we're able to alarm on it, even looking at potentially leveraging metric math expressions, so we can take a few different metrics and then combine those to build some sort of KPI, doing some sort of aggregation, and then alarming on that is a valuable strategy we've seen our customers do. And then combine that with some sort of synthetic testing, be it either CloudWatch synthetics or some other tool, or your own custom-built synthetic tests. And by synthetic tests, we mean we're sending requests to a specific endpoint and then seeing if we get the desired result. And by synthetic test, I mean it's much more than what we would see as like a health check, where a health check is just answering the question, is it there? So do we get a 200 okay? Where a synthetic test can do much more. So we can collect telemetry on how fast we're getting a response back. We can also test specific workflows. So I'll take an e-commerce example of a synthetic test of, we want to test not just does the page load, but are there errors in any of the assets on the assets that are loading? Are there assets that are taking too long to load? And then are we able to do a specific action, such as let's attempt to log into the site, attempt to search for an item, attempt to add something to our cart, and then attempt to check out. And then synthetic testing can then emit metrics for all of those events, meaning that when an issue does occur with any of those critical workflows, potentially we can then be alarmed on that specific activity. So maybe the add to cart button's broken. We would know about that probably pretty fast. Or like a checkout or a sign-in or authentication isn't working. We can determine that relatively quickly with a synthetic test. And then obviously if our workload has a high enough volume, then we'll probably find out shortly thereafter too from user reports. The next step we have is investigation. And then this is where we see, this is normally in terms of like resolving an issue. And if we look at the lifespan of a operational event, most of the time is going to be in investigating and determining what is the root cause for our issue. And the term I'm going to use here is MTTR, or mean time to resolve, or mean time to remediation, I believe is the expression. And when we think about investigation, this is where having well-defined observability, a well-defined observability practice, so we know how we're looking at our application, we know what we're collecting, we have well-defined KPIs, and tooling plays an extent in this as well, of what tools are we leveraging and how well are we leveraging them to be better able to see what's happening in our workload when an error does occur. Another key to this investigation is, and something I'm going to cover on our next slide here, is the idea of being able to correlate logs, metrics, and traces together. And then the power of that correlation allows you to more quickly get to a root cause. And then, of course, the remediation actions. And then this is where having well-defined runbooks, well-defined automated actions, and potentially even looking at like auto-healing type events of when an error does occur, are we able to automatically recover from that error without needing the involvement of a human? Excellent. So in today's workshop, and when we'll be looking at the Amazon CloudWatch monitoring framework, we're going to be looking at the investigate phase, and that's kind of what the focus of this workshop today is going to be on. All right, so now let's speak about the foundation of observability and what we mean by that. So here you'll see three different I guess, we can call them pillars or data types or primitives, whatever we want to call them, but they're metrics, logs, and traces. And each of these are very valuable on their own. So for example, and we'll kind of walk through what we mean by that. So a metric, for example, it's valuable because it gives us a time series data point. We can look at a trend over time. Like I was saying earlier, we can do anomaly detection on that metric. We can also do metric math expressions, but more importantly, what the metrics allow us to do is take some sort of data point, be it a performance indicator or a performance infrastructure data point like CPU utilization, or maybe we can take some sort of application data point and say, look at what's our average response time for a specific type of request, and then put that to a time series. And then the key mechanism here and what it allows us to do is alarm on that data point, meaning that if certain thresholds are breached or if we're out of band, then we can alarm, and then that is our mechanism in which we can start taking action, either an automated action or sending a notification out to some sort of operations team. So the metrics can help us tell that there is a problem or look at overall performance or look at KPIs. Now, the next pillar here is logs. What logs allow us to do are, logs are very rich sources of data, but more often than not, they're not necessarily directly giving us we're not normally alarming directly off of logs. Logs are definitely more useful and looking at that root cause. So let's say we have a metric, we see there's an alarm, being able to identify where that component is in our application, and then being able to pull the logs for that component will normally be heading in the right direction to finding what the root cause is. So the logs are critical in identifying what our root cause is and getting more information on specific errors or requests. And then lastly, we have traces. And what traces give us are can give us a high-level service map of a distributed application, and which allow us to see, one, where requests are flowing, and then where potential bottlenecks in our application are, and then as well as being able to see which components have the highest latencies or highest error rates, or which ones are getting the most traffic. How we leverage trace data at AWS for observability speaking is we're using our trace data to allow us to correlate metrics and logs together. So when we think of observability, we want to think of how can we use all of this data together, and then when combined, this is what allows us to pretty drastically reduce our MTTR, because now we don't have to look in one place for metrics. We don't have to look in a separate place for logs and try to do some correlation there. And then if we are using tracing, that potentially could be helpful. The idea is if we have all of this in one place where we can correlate this data together, from an operational perspective, I do want to say that like it's being operationally excellent. That's what it is. It doesn't necessarily matter if it's in CloudWatch or not. If you're using open source tools, that's great. But the key takeaway here is to move towards observability, you want to have some sort, the critical component is correlation. You need to have a place where you can correlate these different type data points together to help reveal where potential errors could be occurring in your application, and then getting closer to that root cause analysis. All right. What we'll speak to today is the Amazon CloudWatch Monitoring Framework. And what is that exactly? So at a high level, it is a Amazon CloudWatch agent configuration for specific workloads. So this is an opinionated configurations for different CloudWatch agents, as well as application configuration. What we launched with, I think last week we actually launched, or a couple of weeks ago we announced this was for Apache workloads. So we have a tailored, opinionated CloudWatch agent and Apache configurations for that workload. And then going forward, we'll have other tailored workloads as well. And then it also gives us a tagging mechanism to add or remove instances from a dashboard. And what we mean by this is essentially this is solving two problems for us. One is we now have a framework that we can build and extend upon for specific workloads. And then two is it gives us the ability to do build a tagging-driven dashboard. So a dashboard that's driven off resource tags. This is pretty important because it allows us to look at if we have thinking of ephemeral resources, or if we add or remove instances over time, as long as those instances have those tags, then they can be picked up by this dashboard. So those are kind of the two problem statements that we're looking to solve with the monitoring framework. But it's also giving us a few other things. So it's an out-of-the-box CloudWatch dashboard for workloads running on EC2, similar to what I mentioned earlier. And then it's also an automated process to set up a CloudWatch dashboard. This is the solution we'll be walking through today, and then specifically how using a framework like this could help with improving operational excellence when operating on AWS. Now, let's quickly cover the deployment framework and stack parameters. So this framework is deployed as a CloudFormation stack, so the setup shouldn't be too difficult. But what we'll take a look at here is the different parameters. So if we're deploying it, and if we want to deploy a demo instance, a yes or no, and then the tagging schema, which is a key value pair that we want our framework to look for. So in this case, any instance with the tag key CloudWatch dashboard and having a value of Apache would then be picked up by the stack and then added to that dashboard. Obviously, how this works is we have a single CloudWatch stack here, and then we also deploy a child stack, which is an Apache stack, and then another child resource CloudWatch stack, which is a demo. And that's what we'll be walking through today. As for extensibility, the idea is as we add new solutions to this, or it is an open source project, so any other, like if you want to make pull requests, we will be walking into the GitHub repo for that and kind of show you what it looks like to contribute if you'd like to do that. But the idea is looking at different workloads would have their own different respective stacks, so then we can deploy this for the specific workload we're looking for. But let's take a look at the different components of the solution at a high level. All right, so we have user interaction, and this works when we update the EC2 tag with the correct tagging scheme. So in this case, it's CloudWatch dashboard and then Apache. And then of course, we have the dashboard management, which is for updating the Amazon CloudWatch dashboard. So we have our user. We update our EC2 tags with the correct tagging scheme, update our instances. Then we pick this up in Systems Manager Parameter Store, where we store the instance ID. From here, we have a CloudWatch events rule, which kicks off a Lambda function, which will then update our dashboard. So this is dynamic in nature. So as new instances are added with these tags, it will walk through this process and our dashboard will get updated with the correct value. All right, so let's take a look into this a little bit deeper. So from the user interaction standpoint, our first step is we update an EC2 instance. Now we have in the solution, we'll have a CloudWatch event-based rule. So it's a cron-based scheduled event that kicks off every 5 minutes, which will invoke a what's called a tag handler Lambda function. And this Lambda function is then looking at instances to find instances that do have that specific tag applied. And it's comparing that with the list of instances we're storing in parameter store. So do all the instances there still have that tag, or are there instances that, so we're checking for add or removed instances on essentially a 5-minute interval. And then from the updating approach, we have a CloudWatch event listening for changes for that specific parameter, which then invokes a Lambda function, which is responsible for fetching our dashboard configuration, updating it, and then putting a new dashboard configuration. Excellent. So now let's take a look at some of the architecture considerations of like why we decided to do it this way. So one important note here is that while this is all automated, one thing that we don't do, it's done in the demo, and this is something we will do today, but we don't deploy the CloudWatch agent configuration in the solution. And the reason for this is we wanted to decouple the management of your instances, because when we were thinking of deploying a CloudWatch agent and putting a configuration on that agent, and then potentially also updating an application configuration, we wanted to decouple that process from the observability perspective. Meaning that, let's say you can use Systems Manager, and it's a pretty good way to do it, to deploy the CloudWatch agent, as well as to manage the agent configuration. This is a topic we cover quite extensively in the episode 1 of this workshop series, where we use the CloudWatch agent or Systems Manager to deploy the CloudWatch agent, and then from there, use the CloudWatch agent, the Systems Manager parameter store to store our agent configuration and push that out. So if you haven't had a chance to check that out, I highly recommend doing so. But of course, there's other options to deploy your CloudWatch agents and manage that configuration, and we wanted to make sure that that was open to our customers. So really, however you'd like to do it, that's how you can do it however you'd like to. The second why is, why do we use 2 separate Lambda functions? So you'll notice that there was a tag handler and a dashboard handler. And the reason for that being is we want our Lambda functions to be specific in what they do. So one function is specific to looking up tags and managing parameter store, and another function is very specific to updating a CloudWatch dashboard. So since they serve 2 distinct purposes, we had 2 distinct Lambda functions. And then this also gives us the ability to customize and build those functions out a little bit more over time without having to worry about breaking another function. And then last, why are we using resource tags to define our dashboards? Now, the main reason is this is one of the problem statements we're looking at setting out to solve, specifically looking at what tag-based dashboard management is something, from my experience working with customers, is something that's highly requested, and it's something that is pretty important for our customers. And then if we look at some of our other well-architected pillars, leveraging tags correctly and extensively is something that we recommend as a best practice. So if we think of different components of our application, different components are, if we think of like web servers or app servers or database servers, normally we'll try to tag those to what tier or that application is in. So if it's like a web tier or a web front end, we'll have a specific tag for those groupings of resources. But if we want to think of doing component level dashboards for our application, so what does the web tier look like? To do that before the solution was relatively difficult because it's not dynamic in nature. You define your dashboard and that would be it. So you need to constantly look at a mechanism in which we can update our dashboards dynamically as resources are created and removed. And we found that tags would be a good way to do this. And then lastly, we have the CDK to build the solution. And why did we do that? Mostly because we found that to make the solution more easily extensible, so it's not just a CloudFormation template, it's a CDK solution, CDK build, and mostly to make it easier for our customers to contribute to this solution. Let's take a look at a couple design considerations. In this case, we're looking at the CloudWatch agent, and we're using a layered configuration approach. By that, it means we're using two separate config files for our agent configuration. There's an infrastructure config, which has that base configuration for our CPU and memory metrics, but then we also have an Apache configuration for collecting specific memory metrics for the Apache process and logs. And then for the Apache agent, we also are formatting our logs in a JSON format. What this allows us to do is take a look at better leverage existing tooling such as contributor insights, logs insights, and metric filters. And then if we look at how the kit is constructed, we have an infra.ts for deploying our workload-related architecture, a demo for deploying a demo resource, config for which is storing our configs for the CloudWatch agent, and then, of course, the dashboard definition, which is a collection of widgets and metrics for the workload. Okay, so now what we're going to do here is move on to the hands-on workshop section of this lab. And what we're going to do is we'll go ahead and select this link, and this will take us to the solutions page. And in about a few seconds, I'll go ahead and follow along. All right, so with this link will take us to the process of setting up an Amazon CloudWatch dashboard or the Amazon CloudWatch monitoring framework. Specifically, what we're going to be doing is looking at, from our home screen, we're going to go and we can take a look at the solution components. And what I'd like you to select is looking at the base infrastructure config file, as well as the Apache config file. And open these up in a new tab. Specifically, we want to look at the Apache config file. We don't really need to look at the base one too much, but it's open, so let's take a look at it. What we're looking at here is our agent config, our metric collection interval, and then the different logs we're collecting. So we're collecting logs for the CloudWatch agent, for our log messages, auth log, boot logs, and then a few different memory and read and write metrics. Now, for the fun part is let's take a look at the configuration we're using for the Apache. And what we're doing here is collecting at a 60-second interval, and then we can see we're collecting our WW error log and our access log, and we're storing these in a specific log group. So CloudWatch monitoring framework, error, and access, and then the log stream is going to be our instance ID. In addition to this, we're also collecting a few proc stack metrics, so CPU usage, memory, read bytes, write bytes, from this specific Apache process that's running. So we're collecting process level metrics as well as our logs for our specific workload. Now, the idea, like what we want to think about here is the fact that we have the ability to collect process level metrics and then grab custom log files for applications. This is what helps us move from just looking at like a health check or just overall instance CPU and memory to looking at what is our specific application doing. So by being able to collect application specific logs, this gives us the ability to see how well is our application performing, because we can take these logs and convert those into metrics. So we can look at error rate, or we could look at errors by specific requests, or we could look at CPU utilization for a specific and memory utilization for a specific process as well. All right, so back to our documentation here. We have the solution components. We've already covered the design considerations. If you'd like, we can view the different CloudWatch templates here. We don't need to, but like we mentioned, there are 3 different templates at play. We have the framework. We have a template specifically for the Apache workload, and as we add more, we'll have more templates going forward. And then a demo template that's specific to giving us a demo instance. But what we'll walk through today is the automated deployment. So once again, we are on the documentation page for the AWS Solutions Amazon CloudWatch Monitoring Framework, and we're in the automated deployment section, and we'll be walking through a few of these steps. So what we'll need is, and I'll kind of close out these tabs. What we'll need is access to our AWS account, and we'll go ahead and launch the stack. One note on cost. So if we were to run this default solution for a month, it'd be about $3.16. If we were to run it with the demo instance, and we kept it running for about a month. It's estimated to be $13. At the end of this workshop, we'll be walking through a teardown settings, as well as to clean up our workshop so we don't incur this cost. But please note, if you do leave this running, there is a charge associated, so please be sure to stick around for the cleanup steps. But yeah, let's go ahead and jump to the automated deployment. What we'll need is to sign into our management console. This is what I have already done. So I'm already signed into the management console. And we can download the CloudFormation template or use the launch template button here. And this is what I will do. And what this will do is it's going to open up, take us to the CloudFormation console, and it's going to reference this template, as we can see here. We'll select next. From here, we'll name our stack. I'll call this CloudWatch but you can name it whatever you like to. For parameters, we'll use yes. We'll use this default tagging schema, and then we'll deploy the demo instance. For our tags, we don't need to tag it. For permissions, we will rely on the user permissions, so we're not assigning or delegating a role here. We're just going to let the stack use the permissions of the currently signed in user. And then for advanced options, we're leaving these as the default values. And then we'll select next. All right, so here we have our template URL, our stack description, our stack parameters, which are the defaults, and then from the other advanced parameters and tags, all of this is just the default values. Now, what we'll need to do here is then acknowledge that we are going to create some IAM resources, and we will go ahead and create stack. And here we can see our stack is creation in progress. If we look at some of the resources, we'll see it's actually spinning up a couple child or nested stacks for us. And we don't have any outputs yet. So if we refresh here, we should see that there's a couple nested stacks being created. And what we'll do here is, while we wait for the CloudFormation stack to be deployed, we'll go ahead and look at a couple of the resources that are created. We'll walk through how this works. We'll tag our instance, and then we'll walk through that process to see what specifically is being created, and then looking at our output dashboard. Then we'll take a look at what those steps would look like to start extending the solution or configuring it to our specific workloads, or leveraging it in new or existing workloads. But if we look at the create in progress, we have our Apache framework stack. And then if we look at the resources for the demo stack, we can see we are creating a VPC for the demo, a subnet, as well as instance policy, an instance IAM role, and then an instance profile. And then soon we'll see that in EC2 instance, we're actually going to be launching here as part of our demo. The other part of the nested stack is the actual resources we're configuring for our for that architecture we walked through. So we have our tag handler event, an IAM policy, SSM parameters, and a couple CloudWatch events. So while we wait, let's actually take a look at those resources that have already been created. So what I'll do is I'll open up a console in a new tab here. And we can go ahead and take a look at the CloudWatch console. And then from CloudWatch, we can take a look at, we have events and rules. And here we'll see we have two specific rules. We have our Apache EC2 tag rule that's created, as well as the Apache SSM rule. So this is the rule that invokes on a 5-minute interval. So every 5 minutes, this is going to trigger, and it is going to invoke a Lambda function, which is going to look for specific tags for our instances. And while we wait, let's just double check and see if our creation is completed yet. So we're still waiting for this instance to be created. And what I want to make sure we do is once this instance is created, we'll want to go ahead and tag it. Since this is kicking off every 5 minutes, we want to make sure that we have time to go back, tag it, and then walk through the rest of the workshop. So yeah, if we look here, we see create is complete. And I will click on the link for the instance, and then we have our EC2 instance. It is a T3 micro. We'll select it. And we can go ahead and now look at a few of the properties for our EC2 instance. But really what we want to do is go to our tags and note that we don't have any tags. We have the CloudFormation tags applied, and we have a name tag, but we don't have that CloudWatch dashboard tag applied. And this is why you'll see if you do go to the CloudWatch dashboards, you may notice that we don't have a Apache dashboard created. And that's because we don't have any instances that are tagged for that yet. So let's go ahead and manage tags for our instance. We'll add a tag. And what we will name this tag is, if we go to the parent stack or the CloudWatch Apache framework stack, and if we look at our parameters, so these are the parameters we used. So the key, the tag key we're looking for is CloudWatch dashboard. So I will copy this. I'll go back to the Manage EC2 Instances tab. And we'll paste our tag here. So we have CloudWatch dashboard. I'll go back to the CloudFormation tab I have open. And the tag value I'm looking for is Apache. So then I'll take this tag, go back to the EC2 tab I have open, and then we're applying the tags CloudWatch-dashboard with the value of Apache. Please note that tags are case sensitive and trailing spaces count. So make sure we don't have any trailing spaces, and then this is an exact match. This is why I'm copying it directly from the parameters I used. Okay, so we'll save this. And now we have the tag applied to our instance. Now let's go ahead and take a look at, while we wait for that 5-minute process to kick off, let's take a look at the other components of the solution. So from EC2 instances, we'll go over to the CloudWatch Management Console. We'll go over to rules. And then we can see we also have an SSM rule. So this is the event that gets triggered when SSM parameter is updated. Specifically, we have an SSM parameter called CloudWatch Monitoring Framework Apache Instances. So what happens is every 5 minutes, that first rule invokes a Lambda function, which checks to see if new tags are added or removed across all of our EC2 instances. And then it will add the list, that EC2 instance ID, to this specific parameter store. So CloudWatch Monitoring Framework, Apache Instances. From here, what we'll do is this next Lambda function is going to invoke. So once a change happens here, we target a Lambda function, which is going to update our CloudWatch dashboards. I'm not going to take a look at the Lambda functions because we used a deployment package to deploy them, so viewing them in the console isn't going to do us too much good. But you can go ahead and check those out if you'd like to. So from here, we will then go to Systems Manager, and we'll take a look at that parameter store object. So we can jump to the Systems Manager console. And on the left-hand navigation, under Application Management, we have Parameter Store. And here we have CloudWatch Monitoring Framework, Apache Instances, and last modified 1441. And we can see it is 1443. So looks like it was updated a few minutes ago. And what we're looking at here is now it has the value of our EC2 instance. So now if we were to remove this instance tag or add a new instance and have that instance tag, in 5 minutes, this list would be updated to include a new instance ID. So it'd be a string of instance IDs. So what this means is we know that this was updated. We took a look at the event rule, which is looking for updates for this specific parameter. And that's invoking a Lambda function to go ahead and build a CloudWatch dashboard for us. So now if we take a let's jump to the CloudWatch console now. So I type in CloudWatch. If you have the CloudWatch console open on another tab, that's fine as well. I don't, so I'm opening it. And let's go to dashboards. And here we can see we have an Apache dashboard. That's Apache dashboard US-East-1. And this is created about a minute after our instance was added to that SSM parameter store location. Now let's go ahead and select our dashboard. And then we have some metrics here. Well, we probably don't have too many metrics because we're not sending any requests to our instance. So let's go ahead and fix that. So what we'll do is we'll jump over to the CloudFormation stack. And if you don't have this tab open, you can just jump to the CloudFormation service. And what we're looking for is the nested stack that contains our demo. So there are two nested stacks. And what we want to look for is there's an output tab here. And the output tab for our nested stack for our demo should have a web URL for our Apache web server. So I'll copy this. And we have a nice little hello world application. So I will just spam this a few times. And then we could send this from remote remote addresses as well. You can send this from different devices. As long as we have a request being sent. Please note, currently this is sitting on a security group where port 80 is open to the world. So over time, you will get a whole bunch of requests to this instance. And the suggestion is that you either probably clean this up at the end of this workshop or tighten your security group rules so you don't have the entire world sending requests to your hello world application. All right, so with that being said, we made some requests to our workload, and we'll send a few more here so we have something to look at. And we will reload our page here. And now we should start seeing traffic by remote IP, traffic by host, bytes received, requests by status. And it looks like we're doing the, what is this, our loopback address. So it doesn't look like it picked up the request we made yet, but it should shortly. We're looking at the Apache host CPU, as well as we have some metric widgets here for what's called Metrics Explorer. So what Metrics Explorer does is it allows us to do tag-based metrics, meaning that we can take a look at group our metrics for specific tags. So give me all the metrics for, give me like these specific metrics. So memory use percentage and netstat TCP established. Give me these metrics for any instance that has a specific tag. And let's take a look at how this works. So on these little option bars here, the widget options, I'll select edit. And then we can see, we can look at the specific metrics we're looking for, and then the metric statistics. And then I'm doing from CloudWatch dashboard Apache. And then we can also do some aggregating grouping options. But if you haven't used Metrics Explorer, that's what it does. And we can add these to our CloudWatch dashboards. In addition to that, we have a few different other widgets here. So these widgets are powered by CloudWatch Logs Insights. So if I were to edit this, we can take a look at what we're doing here. And we are running a CloudWatch Logs Insights query, which is we're looking for a specific log stream, and then we're counting remote IP as count by the remote IP address. And then we're just give us the top 10. And then that's giving us that visualization here. Now, what I have done is I went ahead and I have on a different account, I have a instance that's I've been running for a couple days, just so we can see what this would look like if there's a few more requests coming. So we can see that I had 2 different hosts here. And then I have a few different IPs making requests. And then we can see traffic by bytes sent, by bytes received, our average response time, traffic by status, our host CPU process, as well as our running resources. In addition to this, I've also extended the solution and added a new widget. And this is something that we can do now. So how can we go about doing this on our solution? What we can do is, in this case, what we'll do is we'll take a look at adding what's called a contributor insight rule. But before we do that, what I'd like to do is we can go to log groups, and let's open this up in a new tab. So you'll see I have 2 log groups created, or log group tabs open. Maybe I shouldn't have so many tabs open, so I'll close out a couple of ones we may not need, such as the EC2 instance one. And what I'm going to do is we can see we're collecting CloudWatch Monitoring Framework, Apache error log, and access log. And this is what we saw from our agent configuration, so this shouldn't be a big surprise to us. But let's go ahead and take a look at the access log. And then we have a couple different log streams here. And now let's take a look at our log file format. So this file format is formatted in JSON. So we have a couple options here like time, process, remote IP, query, status, response time. And we'll keep this open because we'll use it in a moment. And what we're going to do here is we're going to jump to CloudWatch. And so this is our second CloudWatch tab we have open, and we'll jump to the Contributor Insights option here. Now, what Contributor Insights allows us to do is take a look at top talkers or top contributors for specific fields in our logs. So, for example, let's jump back to our log example log file here. So what I mean by top contributors is we could do something as simple as give me the HTTP status and method combination. So I want to see the top contributors for GET requests where the status is 200, or give me requests by remote IP address. So something that's fairly high in cardinality, meaning we can have a whole bunch of remote IPs making requests, but maybe I want to get a time series of which IP addresses are giving us the most requests over time. Or maybe I want to look at requests by request URI. And then if we have many, many different request URIs, we can have that breakdown, or URI by HTTP method, or status by HTTP method. So we can do combinations of contributors as well, which is where I think this really shines. But let's go ahead and make a sample rule here. And we can do create rule. And it's going to switched over to this the second CloudWatch Management Console tab we have open. And if you weren't following along, we are in Contributor Insights. In our rule definition, we will select a log group. And here we have the CloudWatch Monitoring Framework, Apache Access. If you have a whole bunch of log groups in your account, you can just type Apache, and it should bring us up the access logs here. We're going to do a custom rule. We're going to do a JSON format. And let's add some contribution keys. And what's nice here is you can see that we have an auto discovery field. So Contributor Insights, since we are in a JSON format, it's automatically discovering what the different fields of our logs are. Now, what this allows us to do is we could do things like let's do status, and then method. So I have, get, put, post options being our method, and then our status being HTTP status. So 200, okay, like 403s, 500s. And then where this could be helpful is then we can look at, of the requests, what methods are being requested, and then what are the responses of those statuses. Or something we could do is give me maybe another option we could do is, let's take a look at the request. We know this is the request URI, and then we know this is the HTTP method. We could then do a filter and say, what is it? Status has to start with like 4 or 5. It's not a 5 or 5. What this gives us is essentially saying only count requests that are in error, and then of errored requests, so of the 500s we're getting, what requests, URIs, are these requests being sent to, and what HTTP method is being used. So this is a really great example of contributor insights, because what we're doing is it's much more than just a 500 error code of, oh, we have a spike in 500 response time or 500 requests. So we know that this specific instance there's something wrong. But what contributor insights allows us to do is dig much deeper and then start looking at, of the 500s, what request URIs are generating the 500. So is it a login page? Is it a checkout page? Is it a like add to cart option? And then what methods are being used? So are these get requests? Are these post requests? But this is just an example. We can apply contributor insights to several different things. We'll go ahead and like next, and then we will call this chop rule. We can name the rule whatever we'd like to. And then, of course, the rule state can be enabled or disabled. Select next. And we'll go ahead and create our rule. And then very simply put, if we wanted to, we could then add this to a dashboard. And there we go. Now, if we scroll back down, we can see under Explorer, we have our new contributor insight widget here. And then we can just quickly save this dashboard. Now, what I'd like to speak to now is looking at, we'll jump back to the solution documentation. And we're going to walk through what it looks like to what you need to do to extend the solution, and then we'll cover our cleanup steps. So for extending the solution to more workloads, like we said, this solution currently only supports Apache workloads, but we're looking to build support for many more different workloads. But let's take a look at the GitHub README page. And this is going to give us an example of what we'll need to do to extend this. So we have our solution overview. This is all stuff we've covered before. What I'm going to do is scroll down, and we have a customization section here. In this customization section, we're looking at prerequisites, so having Node.js version over 10, and then we'll clone the repository. So we'll clone this repo, we'll build it, and then what we would need to do is, let's say, modify the Apache exports file. Let's take a look at what this is. And if we take a look at this file, we can see that we have our log widget definitions. So we can see this is our logs insights query, X and Y coordinates on our dashboard, X and Y coordinates on our dashboard. So if we want to customize this, we have the ability to. What we would do is clone this repo, modify these files, build it, and then that's going to be able to give us our CloudFormation stacks that we can then deploy. A question you may have is modifying, like, how do I get these XY coordinates? And then how do I get these widget definitions? I would say the easiest way to do this is if we jump back to our CloudWatch dashboard. We can build the dashboard as we would like to, and then under actions, I can go to view edit source. And then here I have the widget definitions for my different widgets. So I have height, width, X and Y coordinates, the type, the properties, and the query for a log widget. So that's a quick way if you're looking at extending the solution. You can build your dashboard in, build out whatever customizations you'd like in the console, modify or configure the dashboard how you see fit. So maybe let's say I want to add a like a text widget, for example. No, not a number. I want to add a text widget, for example. And in this text widget, I want to have maybe links to a playbook or maybe links to give us deeper insights into what these metrics mean. I could do that pretty easily. And then if I wanted this to be something that I include in my templates and then that gets deployed automatically, what I would then need to do is take this widget definition, which will end up being in a JSON format, adding it to this file, rebuilding the solution, which gives us the monitoring framework templates that we can use. And then, of course, if we want to start extending this to other solutions, what you need to do is build out a, a different file here for our dashboard configuration, as well as building out a CloudWatch agent configuration. But let's take a look at our cleanup steps. So what we'll need to do is we'll take a look at our Apache Cloud Framework. So we once again, remember, we have two different nested stacks. One that contains the solution, and then the other that contains our demo. And what we're going to do is we're going to go ahead and delete the parent stack, which should go about removing the nested stacks. And we can see this is a delete in progress. The next thing we'll want to do is we will go back to our contributor insight rules. And we will take the rule that we created, and then there is a delete option. And then we can delete this rule. The next thing we will need to do is go to our log groups. And then we have a few log groups for our Apache monitoring framework. And then in addition to this, we also have some log groups that are being collected. Please note that log groups can be shared. So if you are running in an account that is collecting custom metrics or custom logs, the logs, these log group names may be shared. So in this circumstance, I will delete them, but please note that if potentially there could be other resources using these. And how you would know is if I take a look at the boot log here, we'll be able to tell pretty easily because each log stream would represent a different EC2 instance. So if we see a whole bunch of instances here, it may mean that that log group's probably being used by other things, and you probably don't want to delete it. If this is a sandbox account, so in this case we can see I have an instance from testing a day previous, and then a instance from today. So I know what these two are, and I know I don't need these logs anymore. So I'll go ahead and mark those for deletion as well. Actions, and then I'll be able to delete log groups. I'll just double check that these are the log groups that I'd like to delete, and they are. And then if we go back to our CloudFormation stack, we can see our deletions are still in progress. But that concludes the cleanup steps for our lab. Once again, if you keep the base solution running, it's going to be about $3 a month. And then if you keep the demo running on top of that, it's going to come out to about $13 a month. So please do go about deleting these resources if you don't want to incur that cost. But that does conclude our workshop for today. I'd like to take the time to thank you for attending today's session and would like to open the floor up for questions. Thank you.